So for problem number 1, again we have another bow tie thing. So we're asked to determine if that is similar. Well, we know that they're similar because of the way the question is worded. It says select a valid similarity statement. So to prove that they're similar, I noticed right off the bat that angle NDA is equal to angle YTA, which is equal to 87. So now to prove they're similar, I can do it with the angle-angle theorem of similarity, or similarity postulate. When we were doing the vocabulary, somebody said postulate, and they said, or theorem, and anyways, the postulate and theorem mean the same thing, so you could use them interchangeably. So anyways, so I just need to prove another set of angles, but I noticed that there are, what are these called? Yeah, there's a pair of vertical angles. That's why the bow tie figures are so, they're probably one of the more common geometry questions on the SAT. Anyways, so whenever you see the little bow tie, just know that it'll have a pair of vertical angles, and vertical angles are congruent. I don't need to know what they measure, I just need to know that they're congruent. So the angle-angle theorem or postulate of similarity is based on the fact that I have two triangles with congruent angles, two pairs of congruent angles. So then I would say that the measure of angle NAD is equal to the measure of angle YAT. And it doesn't matter what we know. So, it doesn't matter what it is. In other words, we don't have to know the number value. Similar by angle-angle postulate or theorem. So then, now that I've proven which pair of angles are similar, it's NAD. Oh, it doesn't matter. So, ANDAYT, is it A? Yeah. ANDAYT. Now I'm double checking just to make sure, because we know that D corresponds to T, so what Mr. Adams is doing is just double checking to make sure that they're lining them up. A corresponds to A, A, D corresponds to T, and N corresponds to Y then, okay? Alright, moving on to question number 2, same thing but different, okay? It says, which triangles are similar to ABG? So now let me just write out what ABG is. ABG has this side length that it's 12, this is 12, and this is 10. This is A, this is B, this is G. Now this is just like the problem we did the other day, so I think the big triangle is definitely similar to it, because just like the other problem we did the other day, notice that this is what we call an isosceles triangle. That means it has some congruencies and some symmetries. So this side length is congruent to this, and that means that this angle is congruent to this one. I really believe that it's just going to be, and we don't have to prove it because we just did this the other day, I really believe that triangle ACF, which is the whole big triangle, is congruent to it, because one, angle A is congruent to angle A. And then if I add this up, I've got 12 plus 42 is the total length here, and then 12 plus 42 is the total length here, which is equal to 54. So that means that this side is congruent to this side. Now remember, another postulate for similarity is side, angle, side. In other words, if you prove that the sides are proportional, and that the angles are congruent, then you have similar triangles. Okay, and we know that they are because this is an isosceles triangle. In other words, what do I multiply 12 by to get 54? Heck, I don't know. I can find out real quick though. But it's going to be the same, whatever that number is. The easiest way to find out is to take 54 and divide by 12. So I have a scale factor of 4.5, okay? So I have a scale factor of 4.5. So in other words, if I take 12 and I multiply it by 4.5, I'll get my 54. So if I take this 12 multiplied by 4.5, I'll get 54. If I take this 12 multiplied by 4.5, I'll get 54. Now, I don't need to prove this third side proportionality because I know the angle A is congruent to angle A. Does that make sense? So then my angle is ACF. Or I mean my triangle is ACF. Does that make sense? Does everybody have all this written down? Alright, let's turn the page. Now this is, they call it the triangle proportionality theorem or postulate, but whenever you see these parallel lines, you need to know that this over this is equal to this over this. So let me just start by saying BF, actually let me write it a little bit bigger up here. BF over AF is equal to, so this is the top part of it, BG CG. And that's what they want us to find, is the length of CG. So what I'm going to do is, this is just plug and chug, so I'm going to take and I'm going to plug in B, BF, which is 51 over AF, which is 17, and that's going to be equal to BG, which is 48, and then all over CG. I solved this simply by cross multiplying, so I'm going to say 17 times 48 should be equal to 51 times CG. That doesn't look like a G at all. Okay, so we're going to do 17 times 48. That's 816, and that's equal to 51 times the length of CG. What do I do next? Divide by 51. 16. Okay. Now, an extension of that is what we call the three parallel lines theorem or postulate, and it's just basically the same thing. If you have three sets of parallel lines, we know that AB, we're just going to go down the side here, over BC is equal to whatever this is. Now, I'm not going to label it, but I know that what corresponds with AB with regards to proportionality is going to be 225. And then what corresponds with BC is going to be this 450, because those are the sections that they share, if that makes sense. So now I'm going to plug in the other stuff. They're basically asking us what the distance from A to C is. So let me read the question. I have a tendency to just start doing the math. I really should model that you read the question too. So it says, walkers in the park have different benches where they can stop and rest. How far is it from A to C? So we want to figure out this length from here to here. But obviously we can't figure that out because we don't know what the length of AB is. Okay? So then AB is what we're solving for in the beginning. But we really need to know what the length from A to C is. So We really need to know what AC is. But in order to find AC, and remember that AC is equal to AB plus BC. And we know the length of what BC is, but we got to find the length of AB. So anyways, let's plug stuff in. BC is actually 710. So now to get this thing right, what I need to do is I need to cross multiply. I'm going to say 450 times the length of AB should be equal to 225 times 710. Get my handy dandy calculator out. 225 times 710. Whoa, that's a big number. So this whole thing equals 159750. That's 159,750, and that should be equal to 450 times AB. I'm going to divide by 450 on both sides to get the 450 away from the AB. 450 divided by 450 is 1. 1 times AB is just AB. And now to find this answer, I'm going to take my 159,750 and divide that by 450. 355. So now to find AC, AC is equal to AB plus BC. We know that AB now is the 355 plus BC, which is 710. See, this is 710. This right here now we just figured out to be 355. Okay. So 355 plus 710, 1,065. Okay, turn the page. By the way, you guys are doing excellent today. So one other theorem or postulate that we're going to talk about today is an angle bisector theorem. And the angle bisector theorem, you have to look at this carefully because it looks like, oops, let me put it on the screen. It looks like this is a 90-degree angle and a 90-degree angle. It's not, it's an arc. So that just means that this line segment here, this line segment right here, this one, let me highlight it so you know what I'm talking about. This one right here, that is what we call an angle bisector. Why? Because that line, write this down please so you'll remember it. That line segment is bisecting the bigger angle here into two equal congruent angles. So now the proportionality on this, basically we're going to set up a proportion and solve it to solve for x. Okay? So what is the proportionality? In other words, do I take this over this, and is that equal to this over this or this over this? So that's the challenge that we're faced with. I like to think of what the base of the triangle is. So when you look at it, this line here is technically the base. So if you look carefully, this line right here, that's what we would call the base of the triangle. Guys, it's raining outside, relax. Like you've never had it rain outside while you're in class? So anyways, the base is proportional. In other words, this line segment here is proportional to this one. In other words, I could say 24 over 16. That's how we're going to set this up. So this is the big triangle over the small triangle, and then you could think of this as being the base part. And that's going to be equal to, what line segment is on the big triangle? It's going to be 31.5, and then the other side of the small triangle is just x. Now, if you don't set it up right, you won't get the right answer. Does that make sense? So anyways, we solved this just like all of our other problems. We're going to cross multiply 24. Oh, that threw me off. I looked at the screen for 1 second. 24 times x is equal to 31.5 times 16. So let's figure out what that is. 31.5 times 16, 504. So I got 24x is equal to 504. I'm going to divide both sides by 24. So I'm going to take 504, divide that by 24. I get x equals 21. Now number 6 is the same, but it's different. The proportionality is this is proportional to this, while this is going to be compared to this. So I need to know the length of this. If the total length from here to here is 20 and this length is 8, what's this inside here? 12. 20 minus 8, right? So this is 20 minus 8, which equals 12. So I'm going to say 12 over 8. Those are the base side lengths. And that's proportional to x over 11. Okay? So now I'm going to cross multiply. I'm going to say 11 times 12, I believe is 132, and I set that equal to 8 times x. Maybe Mr. Adams' math isn't the greatest. Yeah, right. So 11 times, but I am awfully tired. Somebody was joking, they said, we need to make sure he wakes up. That was at the beginning of class, because I made some mistakes the other day. I drank a cup of coffee on the way in.
You need two.
I need to. I could tell, I was listening to the video the other day, like, in the afternoon, I have so much, I should record these videos in the afternoon, because I have so much more energy, I'm awake. But I listen to myself, and I could it sounds like I'm barely awake, so I don't know how you guys stay awake while I'm teaching. But to be honest, I don't care. So the next thing that we got to do is we got to divide by 8. By the way, when I have these little side conversations, if you're just watching the video, like, and you don't realize I'm recording it in class and I'm talking to kids, it seems like I'm totally random with stuff. Well, I guess I still am random. So, anyways. Oh, thank you for keeping me on track. A student said it's 16.5. That was me. It wasn't you, but lying. Any questions on that? So the key to all these, obviously, is you got to set them up right. The mistakes, you guys could do the simple algebra. The mistake you're going to make is whether or not you set it up correctly. Now this next one's going to be tricky, because what do I have here? I have x and I have 33, so I need to know the measurement of this. But the measurement of this is going to be 33 minus x, isn't it? All right, well, that's no fun. So I'm going to have x over 33 minus x. And that's got to be set equal to 20 over 15. Oh, did I say? See, there it is. I kept talking about making mistakes. Good thing you guys are awake. All right, so we're going to cross multiply. I'm going to multiply 15 times x. Well, bam with the bacon sizzle. And then I'm going to multiply 30 times this stuff. So I'm going to say 30 times this stuff, which is 33 minus x. So I've got 15x here is equal to 30 times 33. Remember, we got to distribute that. So I'm going to say 30 times 33 equals 990, right? So this times this equals 990. Then I got to multiply that by a negative x, so that'd be negative 30x. Okay? All right. In algebra, when we solve for x, we got to get all the x's on one side of the equal sign. How do I eliminate this negative 30x? Yeah, 30 or 30x.
30x. 30x.
30x.
Wait.
30x.
So calm down. First of all, relax. If I add just 30, can I add 30 to 30x?
No.
No, so it's got to be 30x. Well, I appreciate your enthusiasm. You're doing too much. Relax. So this is going to be 45x over here is equal to 990 here. So then I'm going to divide both sides by 45. Nobody's that excited to do math. Come on. Let's be real. No, just the 45 because I want to... 22. X equals 22. Instead of hating, let's try love. Did anybody go to the Love-a-Palooza on Sunday? Did you really? Wow. Did you? It was fun, wasn't it?
Buddy DJ.
No, I was busy.
I was busy too.
All right, let's not get distracted. We're almost done for today. That's true. All right, so I need to know what x is. So x is in BC. It says find the value of x. X is the length from BC. I'm just going to put that over AC. Now, B has two arcs. What corresponds with B? The other triangle, the angle that has two arcs, which is T. C has three arcs, therefore S corresponds to C. Whoops, I wrote that down wrong. So I do this again. A on my little triangle has one arc, so that must correspond to R. And then C corresponds to S. Okay? I guess what I'm saying is triangle ABC, A has one arc. So A corresponds to R. And then three arc is S. Oh, wait, look at this. Oh, do you see what they did? They did it on purpose to throw you off. If I said triangle ABC, what would you automatically call this? RST, right? Because you're thinking it's in alphabetical order.
RTS.
It's RTS, see? You're welcome. Luckily, I'm on my A game. Coffee or no coffee. That's how I roll. Am I really? Yes. So then BC is X over AC, get on my level, is 36, is equal to TS, which is 84, which goes over RS, which is 63. So now, the reason, I got to think about what I got to say. The reason, if you ever watch Mr. Adams when I do the math, even if I make a mistake, I usually catch my mistake before I'm done with the problem because I have all these little things that I do. I'm double checking to make sure that I have the corresponding parts. A lot of kids would have looked at this and thought R corresponds to A, B corresponds, they would have said RST. But Mr. Adams has been fooled on tests before as a student where they purposefully change that around. And that's intentional. They're trying to throw you off. But by just going through that process of double checking, double checking, you won't get it wrong. Anyways, we cross multiply. 63 times x equals 84 times 36. Okay, relax, calm down. We're all glad you know how to do math. All right, 3,000.
I know the answer.
Okay, calm down. I'm trying to teach here.
It's 27.
Man, you guys
Get on our level.
get on your level.
Get on our level. We did that.
All right, x equals 48. Yeah, I'm recording.
We know.
All right, are there any questions? Let's calm down. We're almost done, guys. Problem number 9. Problem number 9, we got that shadow tree problem again. It says 2 trees are in a clearing. The first tree is 15 feet tall, and then it casts a 6-foot shadow. So it's basically a triangle, right? And then it says the second tree cast a 15-foot shadow. How tall is that tree?
6 feet.
Yeah, that's what I was thinking too as a joke, but no, it's not. It's got to be proportional. So, and then it wants to know how tall that second tree is. Well, it has to be proportional. So I'm going to say x over 15. What corresponds to x over 15? 15 over 6. So now, if you guys put that in wrong, you'll get the wrong answer. That's the important thing. That's why I asked the question. I want to make sure that you get the corresponding parts right when you're setting up these proportions. So I've got 15 times 15, which is 15 squared, is equal to 6. Now this is going to be a decimal because 15 squared, if I remember correctly, is 225. Yep. So 6x, sorry. 225 is equal to 6x. And divide both sides by 6. All right, 35 or 37.5 is what x equals. And then it says round to the nearest tenth, so we just say 37.5 feet because it's already rounded or to the tenth, right? It's not rounded, it's the exact value, but we don't need to round. Okay? Number 10. So we've done this so many times, I think I've memorized this, but we know that AP corresponds to PC or CP, which is what they're asking for, right? The median, CP. Let me write it as CP so you guys don't get confused. CP, and that's going to be equal to, AP is equal to DQ all over FQ. All right, so let's plug these in. AP is 16 over CP, which is 6x minus 10, is equal to DQ, which is 20, which is equal, or over FQ. You can tell Mr. Adams is getting tired. I think we'll stop after this one. Okay, so we're going to cross multiply this times this. So I'm going to say 16 times the quantity 3x plus 10 is equal to the quantity 20 times 6x minus 10. I'm going to push this through the parentheses. 16 times 3x is 48x. Then 16 times 10 is a positive 160. 20 times 6 is 120x, because we can't forget the x. And then 20 times negative 10 is minus 200. Okay? So now I'm going to subtract 48x from both sides. So I'm going to say 120 minus, 120 minus, gosh, I keep hitting the wrong thing, minus 48, 72x. So these cancel and I get 160 is equal to 72x minus 200. I'm going to add 200 on both sides. And I get 360 should be equal to 72x. Divide both sides by 72. Yeah, I think you're right. Is that, I didn't realize, are we having a competition today to see who could get the answer before Mr. Adams? So, nobody cares. X equals 5, right? But is that what they're asking us? No. They want to know what PC is. So PC, CP, same thing, is 6x minus 10, but we now know that x equals 5, so we're going to say 6 times the quantity 5 minus 10, which is 30, minus 10, which is 20. Oh, you didn't shout that out.
I shouted it. I was too late, she got this one. That's okay.
You know what? We can do one more problem. Yep. Yeah, let's do it. All right. So what I need to do is I need to figure out, listen, the area of this great big thing is 2,992. I know what it is. I'm pausing because there are students talking. Don't talk. Listen to me. I'm teaching. So now I need to figure out what the scale factor is. So this process is easy. First thing, figure out the scale factor. For these proportional area problems, I need the first step, figure out the scale factor. 2, square scale factor. And then 3, I either multiply or, we'll do it like this, multiply or divide by the two-dimensional scale factor, which is the square. So the scale factor is, what do I do to 68 to get 17? That's the question. Okay, he says divide by 3, so let's check. 68 divided by 3, no. Is it 4? Let's try it. 68 divided by 4, yeah. So my scale factor is 4, right? So my first or one-dimensional scale factor is 4. What's the next step?
Square factor.
Square that scale factor. So my scale factor then here is going to be 4 squared, which is 16. Now I want, this is the area of the bigger rectangle, so this number should be bigger or smaller than 2992. Smaller. How do I make it smaller? Divide. Man, you guys are smart. You must have an amazing geometry teacher. Yeah, I know, Mr. Deverona. Yeah, I know. Leave me alone. 2992. 187 is the answer.
No, 187 square inches.
Ooh, got all technical on me.